Hello everyone and welcome back to Math 143, Finite Mathematics. Today we begin Chapter 3, Linear Programming, a geometric approach. So far we have worked with equations, systems of equations and matrices. In this chapter we will learn how mathematics can help businesses make the best decisions such as maximizing the profit or minimizing the cost. Before we can solve optimization problems, we first need to learn how to graph linear inequalities and identify their solution regions. By the end of today's lecture, you should be able to graph linear equations, graph linear inequalities, distinguish between solid and dash boundary lines, use the test point method, graph systems of inequalities, determine whether a feasible region is bounded or not. Okay, let's start with the quick review. So, a linear equation in two variable has the general form. A linear equation in two variables has the general form ax plus by equals c, where a and b are not both 0. Right. When we graph a linear equation, the solution is always a straight line. When we graph a linear equation, the solution is always a straight line. Right? So let's get the quick review of the example. Y equals 2x plus 1. So what is the slope of the equation? The slope equals 2, positive 2. Then the intercept or y-intercept, here we have positive 1. The slope is 2, y-intercept 1. This should be familiar from chapter 1. So let's draw the line. Right? So let y equals 0. What happened? When y equals 0, 2x plus 1 equals 0. Then what happened? Negative 1 equals 2x. X equals negative 1 half. When y equals 0, x equals negative 1. Then x equals negative 1 half. Therefore, the line passes through the point negative 1 half and 0. Let x equals 0, then y equals 1. That is the y-intercept when x equals 0, y equals 1. Okay, then let's draw the graph. To draw a straight line, we know that 2 points are enough. 2 points are enough. Then x-axis, y-axis, x equals 0, 1, 2, 3, 4, negative 1, negative 2, 1, 2, 3, negative 1. Okay, so the first point, negative 1 half 0, negative 1 half 0 and 0, 1. So the line passes through the point, negative 1 half 0 here. The line passes through the 2 points. This would be the y equals 2x plus 1 straight line. Okay, then next. Let's draw the straight line here. One more example. Example 2x plus 3y negative 6 equals 0. Again, here we have ax plus by negative c equals 0. Then ax plus by equals c. So 2x plus 3y equals 6. 3y equals negative 2y plus 6. Y equals negative 2 over 3 y plus 2. So the slope of the line negative 2 over 3, y-intercept equals positive 2. Let's draw the line. Okay, y equals negative 2 over 3x, negative 2 over 3x plus 2. Let y equals 0, then 0 equals negative 2 over 3x plus 2. 2 over 3x equals 2. 2x equals 2 times 3. X equals 3. So the line passes through the point x equals 3, y equals 0. Next, let x equals 0. Then y equals 0 plus 2, y equals 2. So the point x equals 0, y equals 2. Again, to draw the straight line, 2 points are enough. X, y, 0, 1, 2, 3, 4, negative 1, negative 2, 1, 2, 3, 4, negative 1, negative 2. Right? Okay, then let's draw the point. X equals 3, y equals 0. X equals 0, y equals 2. The straight line which passes through the 2 points. So we have the line y equals negative 2 over 3x plus 2, or we can say that the 2x plus 3y negative 6 equals 0. Okay, then transition to linear inequalities. So from equation to inequalities, let's see. From equations to inequalities. So now let's make one small change. Instead of y equal, Suppose we write y greater than or equal, y less than or equal, y greater than, y less than. So we can replace that equal sign with an inequality sign. For an example, let's say the equation y equals 2x plus 1. Suppose we write y greater than or equal to 2x plus 1, y less than or equal to 2x plus 1, y greater than 2x plus 1, y less than 2x plus 1. So we can perform 4 types of inequalities. So the inequality sign changes everything, right? So instead of one line, the solution becomes an entire region of the plane, right? So notice that we replaced the equal sign with an inequality, right? So this changes everything. Important. Instead of one line, the solution becomes an entire region of the plane. Okay, so let's say the equation one line inequality many points. That means region of the plane. Okay, so now let's see how to use these inequalities, or how to graph these inequalities. For do that, we wanted to identify the boundary lines. Boundary lines. So the first step is graphing any inequalities to ignore the inequality sign temporarily. The first step when graphing any inequality, ignore the inequality sign temporarily. Right? Replace it with an equal sign. Replace it with an equal sign. Okay, then again we convert that inequality into the equation. So this gives us the boundary line. So this gives us the boundary line. For an example, y less than or equal x plus 3. Here we have the inequality. The y values are less than or equal x plus 3. So when replace the equal sign, inequality with the equal sign, what happened? It becomes y equals x plus 3. Y equals x plus 3. Right? So first, graph this line first. You know how to draw an equation line, it's the straight line. So graph this line first. Okay, next. What should be the next step? Should this line be solid or dashed? The question, should this line be solid or dashed? The rule, use a solid line if the inequality includes the equality. Use a solid line if the inequality includes equality, such as less than or equal, greater than or equal. Because points on the line satisfied the inequality. Because points on the line satisfy the inequality. Okay, then when we use the dash lines, so use a dash line for less than or greater than signs, because points on the line are not included. Not included. So use the solid line if the inequality includes the equality. Use the dash line for if the inequality just less than or equality. That equality sign does not include. Okay, let's see the example. Example. Y less than 3x minus 2. Solid or dashed? Dashed. Y greater than or equal 5x minus 6. Solid or dashed? Solid. Okay. Next. Now we know how to draw the boundary line and find out the solid or dashed lines. This next step, choose a test point. Choose a test point. The test point method. This is the easiest way to determine which side of the line to shade, because for inequality we know that the solution is not just a point, it should be a region on the plane. So this is the easiest way to determine which side of the line to shade. The step 1, draw the boundary line. Second, choose a point not on the line. Step 2, choose a point not on the line. Usually we use 0, 0. Right? So step 3, substitute that selected point into the inequality. If the inequality is true, shade the side containing the test point. If it is false, shade the opposite side. So substitute the selected point or chosen point into the inequality. If the inequality is true, shade the side containing the test point. If false, shade the opposite side. Okay, first draw the boundary line, which can be solid or dashed. Also, second, choose a point not on the line. Usually 0, 0 works well because it is easy to plug that 0, 0 value and take the value. Step 3, substitute that selected point into the inequality. If the inequality is satisfied that point, that means that point is included in the solution region. Therefore, shade the side containing the test point. If when we plug that point into the inequality and the inequality does not satisfied, that means shade the opposite side, because the test point does not include in the solution region, means the test point region is not the solution region. I hope everything clear so far. So all the theory part is here. So you can see the theory part here. Let's see the exercise. Example. Okay. 2x plus 3y less than 6. So the boundary line could be the equation 2x plus 3y equals 6. Okay. Now you can determine the boundary line should be a dashed or solid. Just less than sign, no inequality, so a dashed line. Okay, let's simplify the equation here. 3y equals negative 2x plus 6, y equals, okay, we wanted to draw the boundary line. So when 2 points are enough, when y equals 0, 2 over 3x equals 2, x equals 3. The line passes through the point 3, 0. When x equals 0, y equals 2. So 0, 2. Okay, let's draw the graph. X-axis, y-axis, 0, 0 here. 1, 2, 3, 4, negative 1, negative 1, 1, 2, 3. Okay, 3, 0 when x equals, when x equals 3, y equals 0. When x equals 0, y equals 2, y-intercept. Okay, the line should be dashed, dash line. That means the points on the line will not include in the solution region. Okay, next step, take the test point. As I suggest you, so use 0, 0. We have the inequality 2x plus 3y less than 6. Okay, when we plug this value, 2 times 0 plus 3 times 0, that means 0 less than 6. Yes, 0, 0, the test point, 0, 0, satisfied the inequality. Therefore, 0, 0, the test point is in the solution region. So the solution region would be the region which include the 0, 0. On the other hand, we can say that we have the inequality 2x plus 3y less than 6. Less than 6. The region below the line. The region below the line. The region below the line. Right? But I recommended you to use the test point method because it should definitely gives us the actual solution region. Okay, let's do one more example. Graph y greater than or equal x minus 2. The step 1, boundary line. The boundary line should be the inequality must replace by the equality sign y equals x minus 2. And also we wanted to determine it's a solid or dash one. So we have greater than or equal, therefore solid line. Equality sign with the inequality. That means the points on the line must be satisfied the solution region. So the solid line. Step 2, test point. Test point. Let's draw step 2 graph. The boundary line. So when y equals 0, x equals 2. So 2, 0, 1 point. When x equals 0, y equals negative 2. So 0, negative 2. Then draw the graph. Okay, so x equals 2, y equals 0, and this. Okay, solid line. Then select step 3, test point. Let's choose 0, 0 again. Then substitute it into the inequality y greater than or equal x minus 2. Substitute, then 0, 0 minus 2. 0 greater than or equal negative 2. Yes, it's true. Right? So therefore, shade the region or shade the side containing the 0, 0. Therefore, shade the side containing 0, 0. So the side would be this solution region. Right? I hope everything clear so far. Then you can see the exercises here. You can see the exercises. Pause the video and do the exercises by yourself, and afterward check the answers. Check the answers. Okay, do the exercises. And next, we wanted to consider the bounded or unbounded solution sets. We wanted to consider the bounded or unbounded solution set. for each system of inequalities. So far we have graphed only one inequality. So for a systems of linear inequalities, we wanted to graph two inequalities together, right? As we did in the equations, the system of equations, we have had more than one equation, the systems of linear inequalities, right? Okay, let's see. Okay, let's graph two inequalities together. Suppose we have y greater than or equal x and y less than or equal 4. Okay, first graph two inequalities. So this should be y equals x. This should be y equals 4. And both are solid lines. Okay, so y equals x means the line which goes through the 0, 0, y equals x. And y less than 4, y less than 4, y equals 4, that means the line here. Okay, so shade the first graph first. Y equals x. So y equals x, and we wanted to get y greater than x. When we select the y greater than x region, so let's select the y greater than x region. Where it is y greater than x region. And second, we wanted to select y less than or equal 4. Right? Two regions. The overlapping region is called the feasible region. So that means that feasible region satisfied the systems of inequalities. This feasible region is the solution set for this system of inequalities. The feasible region means the overlapping region. What about the overlapping region here? Here we can see the two solution regions are overlapping, right? So this is called the feasible region. Feasible region. So only points that satisfied both inequalities belong to the solution in this feasible region. So the overlapping region is called the feasible region. Feasible region. And only points that satisfy both inequalities belong to the solution. Okay, let's take one more example. Graph x greater than or equals 0. X greater than or equals 0, y greater than or equals 0, x plus y less than or equals 6. Okay, pause the video and draw the graph, 3 inequalities, and show how the overlapping region is. Okay. Feasible region here. The triangle is called the feasible region. Okay, next. Bounded versus unbounded. So what happens if the shaded region continuous forever? So what happens if the shaded region continuous forever? So that region is called unbounded, no bound. If the region is completely enclosed, it is called bounded. So think about the previous two examples. So the triangle, bounded. Region above a line, unbounded. So you can see that the enclosed, totally enclosed region here, the triangle, bounded. Here we can see that unbounded region, because to the right, to the left, we can see that it's unbounded, continuous forever for the negative x sides, negative x values. Okay, I hope everything clear so far. Then let's go for the exercise. One more example here. So the example, consider x greater than or equal 0, y greater than or equal 0. Is this bounded? So x greater than or equal 0, y greater than or equal 0. We know that x equals 0 means y-axis, y equals 0 means x-axis. So the regions should be above the x-axis and greater than this. So the first quadrant continues forever. The feasible region should be the first quadrant, because two regions satisfied here. So first quadrant therefore it is unbounded, right? It is unbounded. Okay. Here you can see the example. Consider the following system of linear inequalities. 2x plus y less than or equal 4. 4x plus 4x minus 3y less than negative 24. So then which of the following xy pairs is a solution to this system? How to find it out? Given two solutions are satisfied the inequalities or not, equations or not. So if this point, if the 5, -7 and -2, 8 both satisfied the two equation solutions, then the xy pair is a solution to the system. Okay, let's see. First, use -5, -7. Okay, 2x plus y less than or equal 4. By substituting 2 times 5, -7, 10 minus 7, 3. 3 less than 4. And 4x minus 3y, -24. 4 times 5 minus 3 times -7. Plus 21. 41 less than -24. So that means 5, -7 is not a solution to this system. Okay, next, -2, 8. So -2, 8, which satisfied the both equations, therefore is -2, 8 is a solution to this system. Okay, to verify the solution, you can sketch the graph of the solution set. Okay, here are several exercises. Please make sure to try them by yourself. There are several exercises. Okay, let's review today's lesson then. Today we learned the difference between equations and inequalities, how to graph linear inequalities, when to use solid and dash boundary lines, how to use the test point method, how to graph systems of inequalities, and how to determine whether a feasible region is bounded or unbounded. So these graphing skills are essential because in the next section, we will use these feasible regions to solve the optimization problems in linear programming problems. So thanks for watching. I'll see you in the next lecture.